Morning viewers, this is Kasturi Day. Today I'm going to continue with this chapter, this atomic mass and atomic structure and chemical bonding. This is according to class 9 syllabus, ICSE syllabus, class 9. So I'll start today with fractional atomic masses. In my last video, I stopped with isotopes. I was discussing about isotopes. Now in this video, I will start with fractional atomic masses and some more are there to continue. So before I start, I will request you to please to subscribe my channel and also ring the notification bell because that will help you to get the notification as soon as a new video is uploaded. Okay, and if you're liking the video, press the like button, share with your friends so that they can also be benefited from this video, and also do meditate before you start your day. Okay, so we'll start with a meditation. For that, let us concentrate on a point of light. Think that light is a power of energy. Powerhouse, which is giving you the rays which are falling on you, that is creating energy in your whole body. Your whole body is becoming powerful, energized, enthusiastic, a happy person. No tension, your mind, you could be a free person. So today, very happy. Enjoy the flow. So, fractional atomic mass. So, what is that? See, we know that isotopes have different atomic masses due to the variation in the number of neutrons. That is, mass number is different, but the same, they have the same atomic number. And isotopes is there, no? So that we will see that they have different atomic masses, but their atomic numbers are same. Okay. Now, it is observed that atomic masses are not whole numbers. Okay, we will see when we consider as a whole, like in chlorine, we have two isotopes of mass 35 and 37. So in that case, when we consider chlorine as in general, okay, so that time the atomic masses we see that it's not a whole number. Okay, the reason is that most natural elements are a mixture of constant composition containing two or more isotopes. So maximum of the natural elements, they have two or more isotopes and they have a constant composition between them. Okay, like in case of chlorine, it has two isotopes I told you, that is one is 35 and is 37, and they are in a constant, a mixture, constant composition mixture, that is in the ratio of 3:1. That is 75% is 35 and chlorine 37 is 1%. 25%. So like that 3:1 is the ratio. The percentage abundance of chlorine 35 I told you and 37 around 75% and 25% respectively. Therefore, on calculation, it comes out that the average of fractional molar mass of the chlorine is 35.5 AU approximately. Average relative mass, atomic mass of chlorine, how do you find? It is 35 into 3 and plus 37 into 1. Okay, ratio we are converting into actual mass. Okay, so average relative mass. So that will be equal to, as 35 is 3, ratio is 3, and it is 37 is 1. So 35 into 3 plus 37 into 1 divided by 4. 3 plus 1, 4. That means that is 35.5. Okay. Now the atomic masses of most elements are fractional because they exist as the mixture of isotopes of different masses. The atomic masses of most elements, they are fractional because they exist in the mixture of the isotopes which are of different masses. That I told you, that they have some constant composition in the mixture, and that's why their atomic masses are not found as a whole number. Next is, what is the reason of this fractional atomic mass? The atomic mass of most elements are fractional because they exist as a mixture of isotopes of different masses. Since the atomic mass of isotopes are different, so that average atomic mass is calculated for a single element, because atomic masses of different isotopes are different. So for the single element, there will be an average of all the atomic masses. Okay, so average mass will be the total mass of all the isotopes by number of isotopes. Okay. Now, overall, it is said that due to the multiple number of isotopes of a single element, they have fractional atomic masses. Next is isobars. Okay. Now, what are isobars? Atoms of elements have same atomic masses but a different atomic number. Atoms of the same element, they have same atomic masses. Like in isotopes, they had same atomic number, but their atomic masses were different. But in isobars, we see that atomic masses are same, but their atomic numbers are different. Those types of atoms, they form the isobars. That the sum of the number of protons and neutrons together form the atomic mass. Therefore, the number of nucleons present in the nucleus is equal to the atomic mass of an atom. Okay. Now, so it will have the same number of nucleons. All the atoms of the elements, they will have the same number of nucleons. Okay, but their atomic numbers is different. That means their proton number or the electron number is different. Okay? Then the number of protons and neutrons alone will vary, but the number of nucleons or the sum of the protons and neutrons in isobars will always be the same. Some will be the same. Some of the protons and neutrons will be the same. The particular, the number of neutrons or the number of protons, that may vary. Okay. To make the sum equal. Okay, now the isobars always have different atomic structure because of the difference in their atomic numbers. As their atomic numbers are different, therefore, the isobars will have different atomic structure. The number of neutrons make up the difference in the number of nucleons. Okay, so nucleons can vary because the number of neutrons may vary. That's why the nucleons number can be varied. Then, so there are always different chemical elements having same atomic masses. Thus, isobars have different chemical properties. As their atomic numbers are different, therefore, their chemical elements will be different. Okay, and that will create the different chemical properties of the isobars. For example, argon 14. Okay, then potassium 14. Calcium 40, all have their nucleons number same, atomic number, mass number same. But see the atomic numbers, argon has 18, potassium has 19, calcium has 20. Right? Then in the second example, see cesium. Cesium has 76 atomic mass, selenium has 76 atomic mass. But their atomic number, cesium has 32 and selenium has 34. Like that, in the third example, see sodium has 24 atomic mass, magnesium has 24 atomic mass. But their atomic numbers, see sodium has 11, magnesium has 12. Same like that, iron and nickel. Iron has 58, nickel has 58 atomic masses. That is mass numbers. But atomic numbers, iron has 26 and nickel has 27. Okay. Then cobalt 64, nickel 64. Okay. But their atomic numbers, cobalt has 27, nickel has 28. See? This is the thing that these are the examples of isobars. Next is, now we come to bond. not band, it's bond. Okay. So electrovalent or ionic bond. What are these bonds? I told you that when electrons are being transferred from one atom to another atom of the same element, or it is shared, transferred or it is shared from one atom to another atom, okay, or it is gained or lost by another atom, then what happens? It creates a bond, forming a molecule. So when this electron is transferred from one atom to another atom, of one element to another element, okay, so that forms an electrovalent bond, creating a positive ion and a negative ion. Positive ion is one which is gaining, losing the electron, and negative ion is which is gaining the electron. Positive ion is known as anions, whereas negative ions are known as cations. Clear? So electrovalent or ionic bonds are produced when electrons are transferred from atoms of one element to atoms of another element, producing a positive or anions and negative or cations. Clear? Now electrovalent bonds are only formed between metals, okay, and non-metals. Between metals and non-metals, electrovalent bonds are formed. Electrovalent bonds are formed between metals which has a valency of 1, 2, or 3, or valence electrons of 1, 2, or 3, and non-metals have a valence electrons of 5, 6, or 7. Okay. Now, electrovalent bonds are not formed between two non-metals. Okay. In simple words, electrovalent bonds involves the transference of certain number of electrons to another dissimilar atom, which has a tendency to gain the electrons, so that both acquire a stable inert gas configuration. There has to be transference of an electron from one atom to another atom, of one element to another element. Okay, that has to be done. If there is sharing of electrons, then that will not be an electrovalent bond. Now, the compound formed by transfer of electrons is known as electrovalent compound. And the number of electrons that an atom of an electrovalent, an element loses or gains to form an electrovalent bond is called electrovalency. Okay, valency, we know that the number of electrons which has been gained, lost, or shared, that is valency. But here, as it is gained or lost, so that is known as electrovalency. Electrovalent bond it's forming, that's why electrovalency. Clear? Now, due to the presence of the strong electrostatic force of attraction, okay, due to the presence of the strong electrostatic force of attraction between the cations and the ions in an ionic bonded molecules, the ionic compounds are stable. Okay. When there is transference of electrons from one atom of an element to another atom of another element, there is an electrostatic force of attraction, because we know one positive ion is created and one negative ion is created. Okay. And there is unlike forces, unlike charges that will attract each other, and this attraction creates an electrostatic force of attraction. Okay, that makes the ionic bond or electrovalent bond very stable. Clear now? Now come to the properties of some ionic bonds. Okay, the ionic properties, ionic compounds are generally hard solids. You know, their electrostatic force of attraction is very strong and it's very stable. That's why it forms a hard solid. It's because the constant particles are ions which are held by strong electrostatic force of attraction, and they cannot be separated easily because they're very stable. No? That's why they cannot be separated very easily, and therefore they form a hard solids. Then ionic compounds have a high melting point and high boiling point. Because these are non-volatile solids. As they are stable compounds, they are non-volatile solids. Therefore, ions are held by strong electrostatic force of attraction, and large amount of energy is required to break this bond, this force of attraction. Therefore, what happens there? Melting point and boiling point both becomes high. Okay? And these ionic compounds do not conduct electricity in their solid state because they do not generally form ions in the solid state. Okay? They cannot conduct electricity in their fused, molten, or in their aqueous solution. Sorry, they can. Sorry, they cannot. I mean, they can conduct electricity in their fused, molten, or in their aqueous solutions. Okay, but in their solid states, they cannot conduct electricity because in the solid state they do not form ions. But in the fused, molten, or in aqueous solution, they will form ions which are free, and that therefore they can conduct electricity. But in the solid state, the ions are not free and they are held together by a strong electrostatic force of attraction. Okay. And therefore, they cannot be weakened and they cannot conduct electricity. In the aqueous solution, their high dielectric constant overcomes this strong electrostatic force of attraction, making the ions free, they become weak, and they can conduct. Then ionic compounds act as a strong electrolyte on dissolving in water. When we dissolve an ionic compound in water, these compound allows the passage of electric current through them due to the presence of free ions. Ionic compounds are soluble in water but insoluble in organic solvents like benzene and phenol. They are soluble in water, but they are insoluble in organic solvents like benzene and phenol. They cannot dissolve these ionic compounds. Okay, as water has maximum dielectric constant, therefore it decreases the force of attraction between the ions, and thus they make the ions free, and hence they dissolve in water. But in organic solvents like phenol, their dielectric constant is minimum. And therefore, what happens? It increases the force of attraction, which makes the ions more strongly held, and that's why they are insoluble in these organic solvents. Their electrostatic force of attraction becomes more stronger in this organic solvents. On passing an electric current through a fused molten aqueous solution of electrovalent compounds, the ions dissociate and they migrate towards the electrodes. That is, towards cathode and towards anode. Cathode is a negative electrode and anode is a positive electrode. So they move towards the cathode and anode. Positive ions move towards cathode and negative ions move towards anode. Then ionic compounds undergo fast reactions in their aqueous solutions. In their aqueous solutions, they undergo fast reactions because they ionize. So their ions are free, and that's why they undergo fast reactions. Now, an ionic compound is formed in atoms of metals of groups 1, 2, 3. We'll come to the periodic table. At that time, I will show you that what are the groups of 1, 2, 3, and after in the periodic table, they loses electrons to form atoms of the non-metals from groups 5 to 6. Okay. So metals of group 1 to 3, who loses electrons to give it to the non-metals, which are present in the groups 5 to 7. Okay, they are gaining electrons to form the stable electronic configuration according to duplet or octet. The protons of these atoms remain constant during these transfer of electrons. When the electrons are transferred, protons remains constant. Okay. So there are some examples of this. Say sodium 11, that is the electronic configuration is 11, 281. Okay. So it will sodium will lose one electron to form sodium plus. Okay. Then calcium 2 plus will also lose one electron to form calcium 2 plus. Okay. Then chlorine will gain one electron to form one electron. calcium will lose 2 electrons. Okay, but chlorine will gain 1 electron to form calcium chlorine minus, and oxygen will also gain 2 electrons to form 2 minus. See, you can see the electronic configuration. Sodium has 1 valence electron, calcium has 2 valence electron, the last is the valence electron, 281. So 1 is the valence electron, then calcium 2882, that makes 20, you can calculate, and 2 is the valence electron, so it will lose this 2 electron to form calcium 2 plus. Then chlorine has 1 deficient of electron, as it is a non-metal, it is a deficient of electron, 1 electron, it will gain that electron to form the octet. So it will gain 1 electron to form chlorine minus. Oxygen has 6 as is the valence electron, but it will gain 2 electrons to form the octet, and therefore it gains 2 electrons to form oxygen 2 minus, O2 minus. Here. Next is electron dot symbol or Lewis symbol. What is that? It is a Lewis electron diagram. He was a person who was a scientist who gave this dot diagram, electron dot diagram. It is known as Lewis electron dot diagram or electron dot diagram or a Lewis diagram or a Lewis structure. Okay, all these can be called one and the same thing. Is a representation of the valence electrons of an atom that uses dots around the symbols of the elements. Uses dots around the symbol of elements, and the number of dots equals to the number of valence electrons in that. How many electrons one atom has, that will be represented by the number of dots. Number of valence electrons, not all the electrons, only the valence electrons will be shown by the number of dots. These dots are arranged to the right and the left and above and below the symbol. Right, left, above and below the symbol with no more than 2 dots on one side. Okay. So this is the structure of some electrovalent compounds. See sodium chloride. Okay. So you can see the ionic bond that is formed by the sodium chloride. See, sodium has 1 valence electron. So it has C2 on the first shell, second shell has 8, and the third shell, the final valence shell, has 1 extra electrons. That will be transferred to chlorine because chlorine has 2 in the first shell, second shell has 8, and the third shell has 7. So it is deficient of 1 electron. So what will happen? It will get that electron, gain that electron to form chlorine minus, and sodium will lose 1 electron to form sodium plus, Na plus. Okay. So this is the electronic. This is the ionic structure which it will form. Okay, and this is the electron dot diagram. See, it will form like this: sodium plus 1 and chlorine minus 1. Okay, so this is the structure. You can see this is the electron dot diagram. Okay, this is the electrostatic force of the ionic bond which is being formed between sodium and chlorine. This is sodium chloride that is formed. Ionic bond, electrovalent bond. Okay. So this is the Lewis dot diagram, and this is the structure that is formed after combination. Another example is magnesium chloride. Now, magnesium has 2 valence electrons. Outermost shell is the valence shell, and that is, we can see that it has 2 valence electrons. So it will combine with 2 chlorine, giving 1 to each. It will donate the electron. That's why it is forming 2 ions. Okay, magnesium 2 plus it will form, and chlorine, each chlorine will become Cl minus. Okay. So this will be formed. See, 1 electron has magnesium is given here and 1 here. So this is the electron dot diagram that has been. This is the Lewis structure. You can say that magnesium is lost. It will give the 2 electrons from here to here and here to here. So this will be Coulomb force, and the 2 chloride ions will be formed. magnesium chloride will be formed. Next, this is the structure you can see. This structure. Minus 1, magnesium 2 plus. Now, another example is carbon dioxide. See, carbon is giving to, this is giving, it is sharing. Okay, this is not an electrovalent compound. This is a mistake here. This is a shear covalent compound, carbon dioxide. So we move on to the next example, that is calcium oxide. Okay, so it's from the Lewis diagram, you can see the ionic equation is like that. It will lose 2 electrons, one to each, oxygen, it will give it to 2 oxygen. 2 electrons, it will give it to oxygen. So oxygen will gain 2 electrons, and there will be a reduction in oxygen and oxidation in calcium. So calcium 2 minus it will form, and oxygen will form 2. 2 plus, calcium will form 2 plus and oxygen will form 2 minus. Okay, so calcium oxide, you can see. So this will be the electron dot diagram, dot structure. That's slightly easy, but see, oxygen, it has 6 electrons in the valence shell, 1, 2, 3, 4, 5, 6, and it gains 2 electrons from calcium, so it becomes 8. By gaining, it forms 2 minus. See here, you can see this is 6 here, calcium, oxygen, and calcium has 2 electrons. From here, it moves on to this. Okay. So it will form like this. Next will be covalent bond. So I will discuss this covalent bond in my next video. Till then, please go to this. If you have any doubt, please write in the comment box. And if you have any other questions regarding this chapter or any other chapter which I have taught, or you want any guidance from me on any other chapter, you want some tests or any question answers you want to discuss, okay, you can please write in the comment box or send me in my email ID with the chapter which you want to discuss. You can take a PDF file, form a PDF file and send it to me. If you want that chapter to be done as well, you want some question answers on, okay, or any test on it, you can do that. I will prepare the questions for you, and you can answer it so that you can get the benefit. So you can do that. And till then, revise these chapters and subscribe my channel if you have not subscribed yet. And if you like the video, press the like button, share with your friends so that they can also be benefited from this. And please don't forget to meditate. Thank you for joining.